Assalamualaikum and good day. Today we're going to continue for our new chapter, which is Force System Resultant Static Part 1. In this chapter, the expected outcome, we are able to solve the problem of moment of force, and also we can understand moment of couple. For this one, we're going to cover moment of force on part 1 first. What is moment? Moment can be defined as turning force, tendency of a force to rotate a rigid body about any defined axis. Then also we call it torque or twist moment. It is a vector, has both magnitude and direction. And also you have to know about what is anti-clockwise, what is clockwise. In my class, for the positive, I'm going to assume as clockwise, and anti-clockwise is negative. So once again, clockwise is positive. But in some notes, they are using clockwise as negative. As you can see here, when we are trying to twist this pipe, we're going to apply force. So we call that as Fx force. And the center of the pipe here, on the z-axis, going to twist our pipe at point O. And from there, we can know what is the distance, d. If we want to know what is the moment we're going to apply on this pipe, we can call it as MO. Moment at O is the force we apply F times by perpendicular, which is D. So that is moment, and this one is perpendicular angles. Here's some application in our daily life. As you can see here, to cause of motion, for example, when we are pedaling our bicycle, we're going to apply force on our pedal. So this is line of action, so we're going to apply force. That force on our pedal. And the center of rotation, we will get lever arm or D, perpendicular distance. So moment we apply for this case is force times the perpendicular distance. Also in our daily life, when we are trying to open our door, so we going to apply certain moment to ensure we can open it. Also when we are trying to screw anything, so we're going to apply moment. And also when we're going to pull out the nail at certain point, so we're going to apply force, so that also moment. Also in here we can see the tire moving on the road. To ensure the tire or the car can moving, we going to apply torque. And the center of the wheel to the road is the perpendicular distance, and this is part of the moment application. Also when we are seeing someone playing seesaw, that also moment application. Here another example, when we try to change our tire, we're going to use this tool where we're going to apply force on both sides. And from that we know what is the perpendicular distance. So we can calculate the moment we are need to unscrew the tire. And also here we can measure the moment to ensure we can rotate or unscrew these things. And if you realize, normally we're going to have great distance to ensure it's easy for us to unscrew this thing compared to this one. And also when someone playing golf, it also will apply a torque or moment. And also when someone playing baseball and also tennis, that is application of moment as well. In here you can see another application. We are invented something to make our work is more easier. For example, screw, pulley system, lever arm, wedge, and inclined plane. Now, what is moment factor? Moment factor is when moment is bigger, the force also bigger. Take for this an example. When we have a weight here and we have our center of pivot, and we can know what is our perpendicular distance or moment arm. So when we have greater distance and also we have greater force, we will create greater moment. Take this for an example. As you can see here, the weight of this elephant is 1000 Newton, and the perpendicular distance to this point we say as 0 or O is 4 meter. So if we want to know what is moment at O, so force times by perpendicular distance, so force is 1000 Newton times the perpendicular distance, so we get 4000 Newton meter for the moment, and it is clockwise at point O. In here, moment is bigger if at 90 degree. So when it acts at 90 degree, it will create greater moment. In here, moment is bigger if act further from the pivot as I mentioned earlier on. So here is a pivot. We can say as a point O. This is the force we apply. The greater the distance from the pivot, it will create bigger moment. So this is definition of moment. We have to know about the perpendicular distance from point O, and also we have to know what is line of action. So this is line of action. This is our force F, and this is the point of interest, point O. The perpendicular distance from point O is D. So moment at O is F times D. So the direction F to O, so this is action line of F to get to point O is anti-clockwise. So direction for that moment is counterclockwise or known as anti-clockwise. In here you can see, due to F1, F2 and 3, we can time by the D because have the same distance for D1, D2 and D3. Due to that force, this thing going to have anti-clockwise rotation. So this is anti-clockwise rotation. Is also anti-clockwise rotation on plan view. And also here we can use right hand rules. Next, take this an example. We have a beam support at point A and point B at both ends and subjected to force F. So from that we can know the distance from A and distance from B. So this one we call as distance A, this one as distance B. Due to the force we apply here, is going to rotate the beam. So at point A, it's going to rotate clockwise, while on B is going to rotate anti-clockwise. So if you want to know what is moment at A, if F times the distance dA, that's moment going to occur at point A, while at point B is the force we apply times by distance at B. So it will be anti-clockwise. Now let's do example 4.1. For this 2D force system, we need to determine what is the moment about point O. Here is O for case A, here O for case B, and this one O for case C. For case A, we need to draw free body diagram first. So this is free body diagram. So MO, moment about O, is force times the perpendicular distance. So perpendicular distance D is 2 meter and force is this 100 Newton. Therefore, our initial assumption, we take positive clockwise and MO is F times D. So what is our F and what is our D? So our force is 100. To get to point O, for this force, it will cause the clockwise rotation. Therefore, it is positive because our initial assumption positive is clockwise. And the perpendicular distance is 2 meter to point O. Therefore, we get our moment at O is 200 Newton meter. The second one, you have to know which one is perpendicular distance due to this force. The perpendicular distance is 0.75 meter to point O. Once again, be careful. So this one is the perpendicular distance for this case, not 2 meter. So our initial assumption positive clockwise. Therefore, our 50 newtons to get to point O is clockwise. So it will be positive. And the perpendicular distance is 0.75. Therefore, our moment is 37.5 Newton meter. Next, let's do for the third one. So we need to find what is moment at O. For this one, we need to know what is this distance. We know this distance 2 meter, and as you can see here, the angle is given 30 degree. Therefore, with trigonometry, we can find this distance, which is 2 cos 30. In this question, it's given to you. However, if we not given it to you, you should able to calculate by using the trigonometry. And here is your force, 40 Newton. Therefore, from here up to here is the perpendicular distance. So now we can calculate our moment. We take positive clockwise. So force 40. To get to point O, it's going to move clockwise. So it's positive 40 Newton. And the perpendicular distance is 4 meter plus 2 cos 30. Then the answer is 229 Newton meter. Next, do apply the same concept. Try to find what is moment at O for case D and case E. By doing that, you are able to find what is moment due to 800 Newton at point A, B, C and D for this question.